Oh, let me first share the screen. Okay. So, okay. So, hi to all who will be watching this video. And this video presentation is my outcomes evaluation number 5 in Signal, Spectra, and Signal Processing Lab. So, the title that we are be discussing today is Convolution. So, by the way, I am Mellard A. Lucero, 2019-333 BSE CE, a student of LPU Laguna. So, let us go with the laboratory exercise. So, the title of this is Convolution with the objectives of convolve signals and plot the result using Octave. So, first, let us define what is convolution is. So, convolution is a mathematical way of combining two signals to form a third signal. So, it is the most important technique in digital signal processing. Convolution is important because it relates these signals of interest, input signal, output signals, and impulse signals. So we all knew of that. We all knew that input signals encodes a message, and output signals also do, and by also do that, but with the with goes to the output, then the impulse can be used to determine the output of a system to any input using time slicing techniques. This is also called as the convolution. Okay, so let us go with this first item. So we have here the continuous convolution and a sample program for this. So the following exercise will introduce you to continuous convolution of signals and analyze the following codes for signals convolution. So let us first analyze this and do this program later. So first, we have here the t. So this will be the start time and the end time. So this literally 0 is to 0.01 and 5. So basically this will be the start. Then the end will be 5 in terms of time. And then in terms of seconds. And then the variations will be in 0.01. So basically this, by this, we can see that in 0 to 1 second, there will be a 10 variations for, 100 variations for that because of the 0.01. So we have here y1, this the y1, y2, and y3. So this will be the functions that we will be having. So the first one is the step. So the unit step. The second one is the unit ramp. Then the third one is the exponential decay. Then here we have here the conv. So this basically the sorry the this will be the functions for the convolving uh, of this function. So conv y1 y1, this is the convolution of the unit step with itself. That's this because of this y1 y1, it goes with itself. So y1 y2 is the unit step with the unit ramp, and the conv3 will be the convolution of unit step with the exponential decay. So basically, this is the next items will be the parameters in setting the plot. So we have here the plot 1 with the set axis 0, 500, 0, 500. Then the figure 2, plot conv2, then later on, and then so on, so on. So first, let us try to plot this sample program to our GNU Octave. So let me first copy this. Okay, up to this point. Sorry, I got. Okay, copy. Then you should try to open our GNU Octave. Let's wait for the program to initialize. Okay, then you should go to the editor. Then copy this one. Okay, so we'll try to run this file. Okay, let me first. So we'll be OE5, and then we'll be having this as first. Then see. So that it will run. Okay, so basically, based on the program, we have here a 3 figure. Let us first us let us minimize this so that we can see all the figures that we have. Okay, so figure 1, figure 2, and figure 3. So the first one is the convolution of the unit step with itself. Okay, so this is what it looks like. Then figure number 2, the convolution of the unit step with its unit trunk. So this is what it looks like. So basically, this signal and these signals is what we are is what this that what signals that it convolves. So basically, this with y1 and y2 here. So the convolution here command. This is the image that or the plot that it produced. Then lastly, the convolution of the unit step with exponential decay. So this y1 here convolves with this y3. Then this plot is produced. So this is basically the sample program for the item number 1. So let's go for the next one. So explain the output for each of the convolution plot. Okay. Then now plot the convolution plot signals. Use time range from 0 to 5. Okay. We have here a 0 to 5 also. Then set the corresponding axis for each convolution to view the output more appropriately. So number 1, we have here a 3 item. So first, let us do this. So we can do this just by editing our first copied program. So let me first close these figures. Okay. So by the item number 1, we have here two signals. So basically we can delete this one. Then okay. And also we can also delete sorry, we don't need this one. Okay, so basically we don't need this one also. Okay, then let's try to edit the program with this. So we can retain the 0.01 here, this expression. So our y1 will be same there, but we will be having this one. Okay, so this time we will be having here our y1 will be changed into this one because of the given. Then the other one will be in exponent. So we can exponent, what was that? Negative t. Okay, exponent negative t. Okay, then conv 1. So this time we will be having a y2 here. Then close this with this semicolon. Then the figure 1 of plot. Then okay, so we should try this one. So the convolution of y1 this and y2 results to this image or plot of signals. So if we combine these two signals, this signal will produce. Okay, so next let's go with the item number 2. So basically x of t is equal to e negative t use of t e negative. So they are basically two same values here. So we can edit that. So just create a new script so that we cannot be then we can copy it and paste it here. Then edit this one because they are of the same value. Okay, then try this one and acquire and to save. So this will be our number 2. So you can name it a 2. Then try. Yeah. So this is the image of the convolution of these signals. Okay. Number 3. file, new script. Okay, so basically just the same, but we will be just editing the values given. Okay, so we can copy this program to this, then later we will be naming this as 3. So but we can edit this 1 minus exponent. So 1 minus exponent. So we can also enclose this with this, and so that we are not, then okay, art. So we will be having this, change these values to multiply by so t is greater than 0. Okay, so we can try this one, but first we should save this. So just like what I've said earlier, I will be naming this as 3. Save and run. So this is the image of the convolution of the of our third convolution. Okay, so let us go with, sorry. So also I forgot to emphasize that this item number 1 is the continuous convolution. So what is this continuous convolution means? So I have here a text copied from the Google. So continuous time convolution is an operation on two continuous time signals defined by the integral of this formula. So this is discussed. This can be discussed in our theory about these signals. So that is why I will not be elaborating this more detailed into you. Okay. So next, we will be doing the item number 2. Let us go with the item number 2. This is about the discrete convolution. So what is discrete convolution is? So discrete time convolution is an operation on two discrete time signals defined by this integral. So this is the formula, and this is discussed and explained more in detail in our theory. So I will be not explaining this deep. So let us go with the sample. So in order to save more time, I will be doing this given task because to save more time. So I will be discussing the details of this, but the example, the time range of this is 0 to 5. So I will be doing this in our Octave. So in order to save more time, I'll be copying the script of this because it is also the same. So we will just be editing a program of this. So also, in terms of using discrete convolution, instead of using n, instead of using t, we will be having here as n, and the time variation will be deleted, and just the start time and the end time. Okay, so we will change this one. In order to do that, then later I will be saving this as item number 4. So this will be gone, then it will be changed into 10. Then also we can refer to our given. So our item number 1 will be having the 0.4n. So we will be just edit this, then just input our given value. So don't forget the dot, then raise to n. Okay, so this is, then also HTUN. So we can have this, change this into 1 multiplied by, so instead of using t, we'll be using n, then greater than, then it will also have an equal sign here. Then so also, okay, just this is the same. Then since we are dealing with a discrete convolution, we will be changing this into 10 into stem. So this access is no longer needed anymore. So we use stem here because if you remember in our last in my last video, so if we are in dealing with discrete signals, we will be using stem instead of plot. So we can try this one. So let me first save this. So just like what I said, I will be naming this as number 4 because this is our number 4 item or task. Then we can definitely see the convolution of these two sets of signal, two sets of discrete signal. So this is the combined signal of that. Okay, so we can go with the item number 2 here. So basically, this is also the same. We just have to edit the value of this second part. Instead of using UN, we have this 0.6n. Okay, so instead of, you can definitely copy this to save more time. Then just edit this. Then hi. Okay. So this is the image of the convolution of our item number 5 in our task. Okay, so we can go with our the second part of our item number 2. So this is the convolution of finite sequence. So we have here the convolution of discrete signals. X of n is equal to it is a series of numbers. So we have here 1, 2, 2, 3 with h of n is equal to 2, negative 1, 3. So this series convolution with this, or will be combined with this set of set of discrete signal. So in order to do that, we can use the code of this y is equal to conv and the series signals 1 to 2 3 comma, then 2 negative 1 3, then comma, and then 2 negative 1 3, then n will be our 0 is equal to the length y minus 1. So stem, since this is a discrete signals, stem n dash n comma y. So we can definitely copy this in order to save more time. Then we can have a new script here, then copy. Then let us first try the given program. So what will be it looks like? So you can name this as given, then save. Okay. Then we should try to run this. Oops, what happened? Okay, what's happened? Stem NYY. Oops, I thought maybe it is stem. Let us try to do that again. Sorry, because of that. Yan. Because of the hour open na. So this is the image of the convolution of these two sets or series of discrete signals. So let us do our given task. So we have here a 2-item task. So with 2 sets. So basically we will be just change the values that are that is currently input in our program. So 25014, then this will be 4, 1 and negative 3. So just copy and paste it here. Then I will be not saving this anymore. Then I will be just try to run this. So this is the convolution result of these two sets of discrete signals. Okay. Then lastly, the last given. So just copy 2, 4, 6, 8, 10, 12. Copy it here. And the other one, 0.5, 0.5 here. Then try to run this one. Then This is the convolution result of the discrete signals that are combined. Okay, so this basically ends our topic laboratory exercise in convolution. So I hope you have learned a lot from this video presentation, and I'm hoping you are all doing good now, and hopefully this pandemic ends. And thank you very much for watching until the end, and maraming salamat po, and God bless. Okay, stop. Thank you.